first, I would like you to come a bit closer. You are staying too far away. So if you are a coder, if you are a developer, I invite you to sit on the beanbags. If you are a developer, raise your hands. Again. You were more when Mihai asked. So please, raise your hands and come here and sit on the beanbags. Close your laptops and come here. I really mean it. I will come after you. Come and sit closer. And you who are standing, please come here and stay on the beanbags. Thank you. Thank you. It's better now. Thanks. So, one MultiversX developer walks into a bar. And he says, 1 block of beers, please. And then, 6 seconds later, another round. You do know that the round on, OK, it's 6 seconds. It seems we are not here to have fun, right? OK, then let's just talk about network interaction SDKs. First, we will do a short inventory of the libraries that we have that are part of the SDKs, and then we'll see a bit how is the effort on aligning all the libraries from multiple programming languages that we offer support for, and then we'll do a short few exercises to exercises that make your code more changeable and more ready to accept the changes that happen in the SDKs that happen now and that will happen soon. Then we'll have a short glance into the near future in what regards the SDKs. And yeah, that would be it. Are you okay with this? Good. We'll start our inventory with the TypeScript and JavaScript libraries. On the left, we have the ones which are lower level, and on the right, the ones which are more higher level. And I'm curious if you are using the ones on the left. They are the building blocks for your applications that talk to the network, especially the ones in bold. Are you using them? Please raise your hands if you do. The JavaScript ones. Not too many hands. Perhaps hate JavaScript or. Okay. On the right side, we have SDK-DAP, which is an awesome library made by our web team, and for you if you write applications in React. And about Nest.js, SDK Nest.js, you'll hear more a bit about later from Traian. For Python, the picture looks quite similar to the one before because the libraries for Python share the shape, the design, and the implementation of the JavaScript ones. Now, again, I'm curious, are you using the libraries in bold for Python? Raise your hands. You raised 2 hands. Any MXPy fans in here? Are you using MXPy? And those who didn't raise your hands, like 80%, you don't know what you're missing out. Rust. The Rust SDK is the elephant in the room. I won't talk too much about it. Andrei Marinica will a bit later. At first, the Rust SDK was only a framework for writing smart contracts that's on-chain software. However, in time, it evolved to include also components that allow you to talk to the network from the off-chain world, from your application and services. I see Andrei here. I think he's on the main stage now. He will talk a bit later about that. Another grown-up SDK that is used in some MultiversX projects in production is the Go one. And then you didn't raise your hands for JavaScript, so I don't think you know, but Java is also a programming language, sort of. We have an SDK for that as well. Any hands for Go, for the Go SDK? Are you using Go SDK? Good. Java and or C++? Nice. Now, the thing with having libraries that are written in different languages is that they tend to evolve with different designs, especially when they are written by different teams. And they change for different reasons, and they change at different times with different schedules. And this happened to us. We made this mistake, and now we have some libraries which are more grown up, and some libraries which are not, and some that do look similar to another, but some that really stand out and do their things their own way. But we are doing something about that. We are currently working on some specifications for the network interaction SDKs. And the aim is to keep them very, very simple and very easily implementable in most programming languages that we offer support for. They will still be low level. They will be functioning as they are now as building blocks for your applications. And also, in this context, because we want them to stay simple, we will avoid fancy constructs. We will be avoiding fancy design that do not easily suit all programming languages. Because at this lower level, simpler is always better. Now, both the design of the specifications and their implementation is work in progress. And our colleague, Alexandru, is doing a great job on this topic. When you go home, when this is over and you go home, please go on GitHub and check the repository, check it out, and have a look. Until then, though, we will have a short glance on what the specs are, just two small examples. For example, the transaction concept becomes a very simple data structure, while the behavior that's associated to it will be moved to a so-called transaction computer. For example, it will hold logic that allow you to serialize the transaction prior signing, and the logic that allows you to hash the transaction after signing. And another important feature of the specs, perhaps the most important, is that they define transaction factories for almost any type of transaction, including token management operations, token transfers, delegation transactions, virtually any kind of transaction that you would make to talk to the chain, you would be able to create that by means of the factories. And you see here, there is a smart contract call, a simple one, but also one that transfers some tokens. This is the way it will be done. And this is in contrast with how it's done in SDK.js at this moment, for those of you who are familiar with this. So in SDK.js, currently there is the interaction facility, which you are using to create a smart contract tool, but in the specs, that facility is missing, and it won't be added, and it will be deprecated at some point from the implementing libraries, from the SDK, and then it will be removed at some later point. And these kind of changes, removals, we know they are breaking changes for your code. Of course, we are aware of that. So the process of aligning the SDKs to the specs and to bring them to the point that we want to be, it will be a gradual process. There will be gradual deprecations and gradual removal of stuff that's deprecated. Now, we also need to make sure that you cover your part of the story, that your code is changeable enough. And some of you might have code that's easily adjustable, but perhaps some of you don't. Some parts of your code might be more ready to welcome change, but some parts may be more rigid, and it happens, it's the real world. And right now, I've mentioned about those exercises. Just to be on the same page, we'll do a few exercises that you can use to make your code more adjustable to the future changes. Let's start with an easy one. In the left, you see a code snippet that uses the address constructor several times, and suppose that is your code. And on the right, we see a proposed change. Say that we remove the address constructor and we replace it with a static function, a named constructor. And you can see that the code in the left is a bit fragile, because it breaks in several places just because we made this simple change in the SDKs on the right. Now, an easy way to make it more resilient, an easy way to fix this is to take that constructor, wrap it in a function of your own, create address right there, and then use that function, that wrapper, throughout your code. And then, when the change on the right comes, when you upgrade your libraries and you see this breaking change, you will only have to change your code in one place. That's better. And building from the previous example, and if you remember 2 minutes ago, I said that the interaction facility from SDK.js, again, SDK.js, please raise your hands. Okay. When that happens, when that change happens, you will be more prepared to accept it if you, again, define a wrapper. If you find throughout your code places that use the interaction facility, you isolate that code, and then you extract it and wrap it in a function of your own, and then use that throughout your code. Actually, you have two options at the time of upgrading your dependencies and receiving the updates. You have two options. First, you go upgrade your dependencies and then see your code breaking in like 100 places, and then go on Twitter, go full rage mode. Anyone did that? Don't raise your hands. And yeah, the other option is prepare your code in advance. Make it more welcoming to change. And you've got to choose the second option. Another example, also it's an easy one. It's not about breaking change that happens in the SDKs. It's about features that are completely missing or partially missing from the SDKs. For example, a few days ago, 1 week ago, someone asked, is there an easy way to validate addresses on MultiversX using the JavaScript library? And the answer is yes, of course, but it's not a one-liner. So what you could do, if you want to achieve that, you can write a function of your own, is valid address, and implement how it should be right now. Use that throughout your code, and then when eventually the SDK comes with a feature that allows you to do that in a one-liner, you would only need to change your wrapper. I guess I'm saying the word wrapper quite a lot. Maybe it's annoying for some of you who are sitting on their phones. You should write wrappers. They will escape you from great damage. Here, we have another example that handles the network providers. Maybe you're accustomed to them if you've used the JavaScript or the Python libraries. And we have, say you did your homework. Now, you know, on this example, you already know that you should wrap the constructors of important components in functions of your own, and you use them throughout your code. But let's say that this happens, and this is just a pure thought experiment. We won't change that. Don't get angry yet. We won't change that. It's just an example. Say that we drop send transaction, the singular form of sending or broadcasting a transaction. And say we only keep send transactions, the plural form. Now, what would you do? What's the answer? That magic word. What's the magic word? It is to write a wrapper, right? So you write a wrapper. You create your custom network provider. And even if we may drop that send transaction, the singular form, you can still keep it. You can still have it in your code. And use it how you did before. Now, here we see how you would use that custom network provider, the one you've defined. And here in the example, you are using it through an interface for even better decoupling. And if we go before, we see this. This looks similar to which design pattern? If you are talking about wrappers, and if you see that, does it resemble a well-known pattern, a well-known design pattern? Is it what is it? It's a what? Right. This one. If you look it more closely, it will be a more specific one. You could also see that. So if I said, it's an adapter. It's a wrapper. It's an adapter. And for example, this one, because adapters come in very many flavors. In this one, you would receive the custom net. You would receive in your custom network provider your adapter. You would receive the default network provider as a constructor parameter. This was the last example. And now the lesson is when you get a chance, when you get the time, and you should take the time, go throughout your code base, scan it, and look for places that depend on our libraries, and also on other libraries which are third parties to you, because MultiversX libraries are third parties for your code. Scan your code and look for those parts, and think of how could you make that pieces of code more changeable and more easily adjustable in case of changes. Now, let's see a very, very short notes of what's happening next about the SDKs. First, we assume that a good and sufficient version of the specs will be ready anytime soon. However, we still have to brainstorm some things, such as contract ABIs and relayed transactions. And of course, during this and following this, there's also the effort of aligning all the libraries to the specs. A short note, for the SDK wallet, the specifications are already done. So if you are going and checking out the specs, you would see that. Now, of course, we also have to update the existing cookbooks. Any of you have gone through the cookbooks on our docs? Please raise your hands. That's not good. Not good enough. We have to, the cookbooks are ways to allow you to jump easily into the code. They are written for the TypeScript libraries and for the Python ones. Basic flows. basic use cases, they are covered in a pretty nice way. And of course, as we change the SDKs, we also have to change the cookbooks, and we also have to replicate them for other programming languages. We only have for 2 right now. The MXPy fans, again, raise your hands. V9 is expected to happen anytime soon. I will let you know. Alex has prepared some very good features. For example, the Rust installation flow is much improved now. And also, the integration of the SC meta tool into MXPy is now much better. And about SC meta, which is part of the SDK, Rust SDK, you will hear from Andrei a bit later. That I would have loved to say that many of you have used the SDKs. However, I won't say that. I will only say that please go and check them out, check the docs out, check our GitHub out, and search for the MX SDKs. And also, if you feel like coding, some of you that feel like coding, please go on GitHub and hunt for issues that have the label help wanted. In the end, I'd like to say a thank you for everyone that's involved into coding, writing, designing the SDKs, reviewing them, especially reviewing them, whether they are part of the team or they are developers from the community. And a big thank to you that use the SDKs. And for the others, I'm not sure what are you using, what else are you using to talk to the network. I'm really interested. I will come down and I will see. I will ask you, each one of you in part. Thank you.